Hi, everybody. Welcome to February's meeting of Cincinnati Software Craftsmanship. I am so excited to have you here today and excited for our speaker as well. So I want to invite you all to show your love for Cincinnati Software Craftsmanship by joining us on meetup.com. That's probably how most of you found us, but it's possible you found us from other ways. Also, by following us on LinkedIn and Twitter, that's where we publish all our updates, all our details, get all the cool promotional copy and videos. It's a lot of fun, and we enjoy it. Also, you can subscribe on Twitch and YouTube to make sure that you don't miss any of our videos. Also want to say thank you to Kroger Digital for sponsoring the meetup. And also to JetBrains. Stick around after the meetup. We'll be giving away a license for a free JetBrains product. So stick around for that. Also want to talk about our upcoming meetups. This is very exciting. Next month, March 3rd, we're talking about JSON data modeling in document database with Matthew Groves. And luckily enough, we have Matthew Groves here today to tell us about his talk. Matthew, welcome.
Ahoy, everyone. Thank you for having me here. And I'm looking forward to speaking at your next meetup next month. I'll be talking about JSON data modeling in document databases, so-called NoSQL databases. I'll be comparing and contrasting them with relational databases, so-called SQL databases. So how is the modeling similar? How is it different? And I plan to even show a demo of a tool that I'm working on, still very much work in progress, to migrate data and other concepts from SQL Server to Couchbase Server. So even if you don't want to navigate those specific waters yet, I think it's still a useful exercise in data modeling. So make sure to come back on Wednesday, March 3rd. Bring all your questions, and I'll see you then.
Thank you, Matthew. I think it's going to be a lot of fun. I really appreciate you doing that for us. So appreciate it. All right. Next, on April 7th, we're going to be doing an intro to application architecture and scalability. That's going to be presented by Matthew Eland. And I plan to have him on next month, and we'll definitely make sure that we have a nice graphic for that one as well. Finally, I want to say welcome, Tyler. You ready for this, Tyler?
Yeah, thank you for having me.
Ready or not, here we come. Can we get some applause in the chat for Tyler? Let's see, show your appreciation. So thank you, everybody. And Tyler, tell me, what time is it, Tyler?
That's a difficult question. Depends upon where you are.
All right. So true. I'm going to give you the stage. Let's add in your slides here, and I'm going to get out of your way.
Cool.
Thank you so much.
Michael, thank you for having me. Again, my name is Tyler Jennings. This is What Time Is It Anyway? Before we get started, just a little bit about myself. I am a senior consultant at ResultStack. We are a consulting company based in Knoxville, Tennessee, but we solve hard problems all over the world. We literally have clients on 3 continents. Because of that, we have, a lot of challenges we have to solve around date time. We have lots of challenges we have to solve around scaling and architecture. And, I just want to say that we are hiring. So if you're looking for a new opportunity where you get to solve hard problems and, solve some unique challenges, please come talk to me. I'd love to tell you more about what we do. I'd love to hear about your background. Or if you're happy where you're at, but you're thinking, you know what, we could use a little bit of help to get over our next hump on the project we're working on. Again, we'd love to help out. So just come talk to me. But without further ado, we are going to be diving into date time. This I'd love to say like this is every developer's favorite topic, but I can't say that with a straight face. Everywhere I go, I hear people have complaints about, some problem they've run into with date time. And this is just a hard problem to solve. Now, what we're going to be doing tonight is I am not going to be telling you, oh, here's how to solve your problems in JavaScript or .NET or Elm or Elixir or Java. This is not a language-specific talk. This is a talk focusing on the ground up of what is the problem that we have to deal with here, and what are some of the known gotchas. How do you need to think about your applications? This is a big topic. So to start out, we're going to look at just a few pieces of trivia to kind of highlight some of the stuff that's out there that I think a lot of people aren't necessarily aware of. The first one is Samoa. Samoa doesn't have a December 30th, 2011. I want that to sink in a little bit. Within the past decade, a modern civilized country is missing a day that everyone else has. Now, there's good reason for this. In 2011, Samoa changed their UTC offset from -10 to +14. So they went from the westernmost time zone, furthest behind UTC, to the easternmost time zone, furthest ahead of UTC. Now, logistically, this makes sense because Samoa does a lot of trade business with Australia and New Zealand, and having to cross the international date line every time you want to travel to those countries makes it really hard to plan things out, because you're losing a day or gaining a day every time you cross an invisible line in the ocean. They also wanted to be the first place in the world that would celebrate the New Year. So that would bring in extra tourism dollars. So economically, financially, logistically, this decision just made sense. The problem is the implementation of that decision. So the change took place on December 29th, and they went from 11:59 p.m. December 29th to December 31st, midnight, except going to +14 hours. They completely skipped a day. If they had made this change, say at 2 a.m., then December 30th would still exist, and it would be a viable option to say you had transactions in your application that happened on December 30th for Samoa. But with the way this happened, it's not actually accurate to say they had any, that you had like banking transactions or, any sort of transactions on December 30th. And this isn't ancient history we're talking about here. This is within the past decade. The other interesting bit of trivia I found when researching this is while Samoa is missing a day that everyone else has, Sweden actually has a day that no one else in the world has. Now, fortunately, this one was long before computers. So, people didn't have to write software around this, but it's still very interesting to think about. So, if you go back between the 16th and 18th centuries, countries were switching from the Julian calendar to the Gregorian calendar. And most of the time they would do this by skipping like a week and a half at once. Now that obviously has its own interesting problems to think about, if you're just skipping a week and a half. But, again, this was pre-computer, so not, I guess, as bad. So as an example, Great Britain in September 1752 went from September 2nd to September 14th. However, Sweden said, we can probably do this better. And their idea was, we're going to skip leap years for the next 40 years, starting in February 1700. And we'll gradually transition to the Gregorian calendar. Think about that. That would make Sweden different from every other country around them. All the other countries are going to be either Julian calendar or Gregorian calendar. And they're going to be somewhere in between. However, things didn't quite go as planned. So they skipped the leap year in 1700, and then war broke out. And as you can imagine, they forgot to skip the leap year in 1704. And they forgot to skip the leap year in 1708. By the time they realized what had happened, they didn't really know how to fix this. If you know the differences between the Julian and the Gregorian calendar, like there's a lot of like precise timing of days and how leap years are done, and there's a lot of math there. I give people credit in the 1600s. You had people who realized that the Julian calendar wasn't accurate enough and actually came up with the rules of the Gregorian calendar we follow today. And they didn't have computers. Like they came up with that by like staring at the sun and the moon and the stars and all that. So Sweden ended up in this conundrum where they just forgot their plan 2 years in a row, or 2 leap years in a row, and their solution to fix it was they said, well, we'll go back to the Julian calendar. So they would go back to the Julian calendar and they would start over. But the problem is, in order to go back to the Julian calendar, they had to insert the day they skipped in 1700 because they skipped the leap year in 1700. So they could have said, well, you know what, we'll make 1709 a leap year. But instead they said, let's have a double leap year. Let's make 1712 a double leap year and have a February 30th. And so, there you have it. Sweden has a February 30th in 1712. No other country can claim they have a February 30th. And in 1753, Sweden finally got their act together and switched to the Gregorian calendar by doing it the normal way and skipped 11 days. I'm not even sure I can call that like the normal way, but there you have it. That's what they did. My last bit of trivia has to do with the Unix epoch. Most people think of the Unix epoch as it's midnight, January 1st, 1970, UTC. But is it? You see, UTC didn't exist until 1972, 2 years later. So some people say, well, it wasn't UTC, it was Greenwich Mean Time. Well, not exactly. You see, at the time of the Unix epoch, the time in London was observing British Standard Time. Now, this time zone was introduced in 1968, and during British Standard Time, the UK did not observe daylight savings time, but instead they observed an equivalent of what would be considered a UTC +1 for the entire period. That is until British Standard Time was discontinued a year later in 1971. So you have this time zone that only exists for 3 years. And so what do you call the Unix epoch? Like, it's the equivalent of midnight UTC, but it's not really UTC. So if you were to look at the Unix epoch in the Europe-London time zone, then it would be 1 a.m., not midnight. Another fun fact is if you were in the pre-presentation meeting, I mentioned Postgres has a date time type of Julian day. And a Julian day is the number of integers from November 24th, 4714 BC at midnight UTC. Again, there's this time like almost 7,000 years in the past that people say is UTC, when UTC didn't exist until 1972. So interesting tidbit there. I'm still not convinced why you would any modern applications would use a Julian day. I understand like ancient history. So maybe in the Zoom meeting afterwards, somebody can prove me wrong, because I can't really come up with a modern use for it. The Wikipedia page says some software will use it to calculate a number of days between dates, such as the manufacture date and sell by date. And I don't know, I do kind of do a lot of work for restaurants, and we've never felt the need to pull out Julian days to calculate between manufacture date and sell by date. But please, somebody prove me wrong of why I should use that. So we'll move on to what I consider the problem. In order to handle date time well in our applications, we need to have a thorough understanding of what is the domain we're actually dealing with. This is a complex domain. First off, you have to understand what calendar are you actually working with. Are you working with the Gregorian calendar, which is the international standard? If you're in the US, then yes, that's what you've probably always known. But there's many other calendars. There's the Hebrew calendar, which is used both religiously and civilly in Israel. And it has an entire leap month. And the year can also change in middle of a month. Think about that for a minute. Then there's also the Iranian or Persian calendar that's used in Iran and some parts of Afghanistan. There's the Ethiopian calendar, the Julian calendar, the revised Julian calendar, the Islamic calendar, the Hindu calendar, the Buddhist calendar, which is used in some places like Cambodia and Laos. And there's many, many others. So what calendar are you actually working with? Well, the good news is if you know what calendar that a date time belongs to, then you can easily convert that date time to any other calendar system. And if you're writing software to be used globally, that may be a very real need. But if you don't know what calendar that date time belongs to, then you can't really convert it to anything else. But let's get a little bit more basic. Think about durations. Think about days. How long is a day? Is it 24 hours? Is it 23 hours? Is it 25 hours? If you deal with daylight savings time, then the answer is yes, yes, and yes. With daylight savings time, you have to deal with at least once a year where a day is 23 hours and at least once a year where a day is 25 hours. So days aren't always consistent in length. And months, we all know that months aren't the same length. They vary from 28 days to 31 days. And it's not consistent from year to year. Does February have 28 days or 29 days? It depends. And if you're Sweden, you could even say, well, 30 days. Let's consider this bit of C# code. We have a new date time, 2020, January 31st, and we add 1 month to it. What does it mean to add 1 month to a date? How many days are you adding? The result you would get is February 29th, which has a difference of 29 days. Let's do the inverse. Let's take February 29th and let's subtract a month. Are we going to subtract 29 days? What are we going to do? What does this mean? No, we would get January 29th, a difference of 31 days. So, .NET has, built-in functions for adding and subtracting months, but, it doesn't always mean the same thing. And I see, JavaScript, we're getting into JavaScript territory here. JavaScript is known for its, issues, with, zero-based months instead of, 1-based months. So you get a month and it's like month zero. What is month zero? Every language has these gotchas. Some are, obviously worse than others, or they stand out more than others. But these are things we have to think about. What does it mean to add a month or subtract a month? Like, what are you going to get? If you're doing financial reports, then a lot of companies want to see consistent time spans, and even like fiscal years aren't strict like calendar years, because the 2020 fiscal year could cross over some into 2021 or 2019. So what does this mean if we're adding a month? You don't want to use that when you're saying, like, here's our financial reports, and if it's not a consistent number of days, then that can greatly skew your data. And the same is true for years. Years aren't the same in length. Are they 365 days? Or are they 366 days? Yes, it all depends upon when. So again, these are not very straightforward answers. But let's talk about daylight savings time. The good news they tell us with daylight savings time is you get more daylight during awake hours. The bad news is they're really lying to you. You're not getting more, daylight at all. It's all about perception. They're not manufacturing more light. It's just a perception. It's also not standard. Not everyone follows it. Sometimes you skip an hour. Sometimes you duplicate an hour. What does it mean when you duplicate an hour? I've seen businesses kind of get caught in this if they operate 24 hours a day and they haven't thought about the problem of an hour being duplicated. What does that mean? What does your data look like? Can you refund a transaction before it happens? Like what? How you store that is critically important. Time zones. The good news with time zones is that they create a standard time for a particular geography. The bad news is that standard is completely destroyed by daylight savings time, so it's no longer standard. I've heard it mentioned with Indiana that that it's can be kind of weird, or it used to be kind of weird with different counties having kind of different rules. Arizona is a huge example of this. In Arizona, you have the different Indian tribes. Some follow daylight savings time, some don't follow daylight savings time, and you have pockets that are one way, and then pockets inside those other pockets that are the other way, and it can be kind of weird. The rules for time zones can change, and as we saw with Samoa, that can have huge effects. Like whole geographies can just change time zones. That's probably something we don't think about a whole lot when we're writing our applications. Like, what if some state just completely changes time zones? Like, what does that mean for our applications? How are we storing our data? Also, things like UTC, that's not a time zone. A time zone has to be tied to a geographic place, and UTC is not tied to any place. Also, this is kind of a pet peeve of mine, but things like -0400 is not a time zone. -0400 says this time is 4 hours behind UTC. It says nothing about where that time is or what the rules that it follows. So, that's kind of a pet peeve of mine. Time zone offsets are not the same as time zones. Let's look at an example. Here we have a date time, October 26, 2014, 1:59 a.m., -0400. If we add 1 minute to this time, what do we get? Well, it largely depends, because if you're in Knoxville, Tennessee, it would be 2 a.m., -0400. But if you're in Cancun, it would be 1 a.m., -0500. You see, when Cancun observed daylight savings time, they actually no longer observed daylight savings time. But when they did, they actually changed daylight savings time a week ahead of the continental U.S. So -0400 doesn't really tell me anything about where this time is or what rules it follows. There's other problems with time. What does time of day really mean? Is that the time elapsed since midnight? Is that the time elapsed since the start of the day? What about daylight savings time? Is 10 a.m., is that 10 hours since, the start of the day? Or midnight? Is that 9 hours? Is that 11 hours? Yes. If you observe daylight savings time, then there is at least one time a year that 10 a.m. is 9 hours since the start of the day, and 10 a.m. is 11 hours since the start of the day. What does time of day really mean? And we mentioned midnight. What does midnight mean? Is that when the clock hits 00? Is that when the clock hits 12 a.m.? What about the start of the day? Because in some calendars, the start of the day actually starts at sundown. Our general 7 p.m. would be, the start of the day and the transition of the day. So is midnight the transition of the day? Is it, what does that mean? And it's also important to know that midnight doesn't always occur. So in Brazil and several other countries, daylight savings time transitions from 11:59 to 1 a.m. when it's springing forward, completely skipping midnight. And when it's falling back, it goes from 12:59 a.m. back to 12 a.m. So in theory, occurring twice in the night. So how do you model all-day events? Again, what does that mean? If you have cron jobs on a server that need to do, background processing of data, you need to be careful of how you schedule those. What if you woke up one morning, logged on to the server, and realized your cron job didn't run because that time didn't happen? Or that the cron job ran twice because that time occurred twice? These are things that you should consider when you're building applications. So we've talked enough of the doom and gloom, and here's all the high-level philosophizing of what are these concepts? What are some of the problems? What are some of the gotchas, or just things to consider? Let's talk about some tips. There are no hard and fast rules. This is another, pet peeve of mine. If I often hear, "We'll always do X," and you'll always be safe. And I want to say unequivocally that is not true. There is no one-size-fits-all solution. You need to consider the data that you have. What is the goal that you're trying to achieve? What domain are you working in? And then you can make a well-informed decision about how you need to handle that time. So my first tip would be kind of back to my previous pet peeve of do not store date times with an offset. January 1st, 2021, 8 a.m., -0500 is not a time zone. Is that Eastern Standard Time? Is that Central Daylight Time? If you're in SQL databases, you have, Eastern Standard Time, U.S. Eastern Standard Time, Central Standard Time, U.S. Central Standard Time, and there's a difference in how those work. So stay away from date time offsets. It sounds like it's good in theory. It sounds like it tells you information about that date time, but in the end, it can leave more questions than answers. Do not store what you don't have or don't know for sure. If you don't know the time zone, don't guess at the time zone. Don't say, well, they say they're in a -5 offset, so this must be X time zone. You might not be right. I've also seen in the wild, a lot of devices that travel when they're doing online ordering. They don't always update their time zone. You think I carry my smartphone and I cross a time zone boundary. If you're lucky, that is adjusting your time zone. even riding in the car with my family, I've seen my phone will adjust time like the minute we cross the the time zone border, and another phone in the car could be like hours later. So if you see data in your application, a customer submitted something to you, and maybe you're sending up a time zone offset, don't try to guess that, oh, well, this must be their time zone, because that might not be right. Do not store a date as a date time. If the time is unnecessary, leave it off. Another thing I've seen is people storing dates as date times, and you pull it out of the server, depending upon the database, depending upon the language you're programming in. I've seen some funky stuff happen. If it's a date time, some databases, some languages will want to convert that automatically to, say the time zone of the database or the time zone of your API server. And if you just need a date, just store a date. Don't store it as a date time. On that same topic, birthdays. Birthdays are not a date time. I mean, in theory, if you are born on a date at a time, like, okay, birthdays are a date time, but that's not how we use birthdays, right? When we're writing applications and, you might ask for a user's birthday, you really don't care what time they were born at. You want to know, is today their birthday? Sometimes you might want to know, how old are they? But you never care about the time. Birthdays are not a date time as far as we are concerned most of the time. I'm sure there's examples out there where, yes, you care about the time. Hospitals probably being one of them. But, even your family doctor does not care if you were born at 8 a.m. in the morning or 3 o'clock in the afternoon. That's just not something that that we generally care about. We want to know, is today your birthday? So I recommend storing birthdays in separate columns, storing the year in one column, the month in one column, and the day in one column. That way you can easily check in a very small query, is today their birthday? If you can also calculate age. If you need a date column, then if your database supports computed columns, most modern databases do, then have it calculate in a computed column what the full date value is. But oftentimes, we don't really work with birthdays that way. So, store birthdays in separate columns. Do not make assumptions. Never assume, I've heard this one before, that, well, we don't do business during like daylight savings times transitions, so we're just not going to worry about it. You never know what's going to happen in the future. You never know how businesses will expand or how businesses change. Don't make assumptions that, well, we're going to take a shortcut because we don't have to deal with that now. You never know what's going to happen in the future. Also, never assume that the daylight savings time rules or the time zone rules won't change. We've already seen, example A, Samoa, where they change, complete time zones to the other side of the international date line. Like, this kind of stuff happens. Don't assume that a whole region won't just change time zones. This stuff happens. We might not think about it very often. It might not be, on the front page of the paper, but this stuff happens, and it happens pretty regularly. This next one's a bit interesting. Store all data you have about a date time. This is where it kind of depends, right? So if you're working with historical times, say you're storing timestamps. This event happened right now or into the past. It's pretty much safe to use UTC. I've often seen people give advice of just always use UTC and your problems go away. And it's like, well, no, first of all, but it kind of depends upon what you're doing. If you're doing historical stuff, you're doing timestamps right now and into the past, UTC is pretty safe. You're doing stuff a day into the future. UTC's, probably pretty safe. So let's consider this example. This is comes from real experience that I had at a job. We operated call centers 24 hours a day, all around the world. There was a lot of legacy code. And these call centers are receiving or taking calls with customers for various things. Some of it was banking, some of it was customer support for various industries. And consider the scenario where a person's on the phone. It's 1:45 a.m. before falling back to end daylight savings time. Remember, in the continental U.S., daylight savings time pretty much would change. If you're falling back 1:59, it'll go back to 1 a.m. And let's say this call lasts 30 minutes, and you need to record the start and end time, and you need to record the duration of that call. 30 minutes later, the clock on the wall is going to read 1:15 a.m. because you fell back an hour for daylight savings time. How do you record how long the call lasted? The correct answer is store this in UTC. So you would record the call start time as 5:45 a.m. UTC time, and the call end as 6:15 a.m. UTC. Yeah, that call never happened. When I arrived at this company, they had opted to not use UTC, and they stored everything in the time zone of the data center. Now, this operated stuff worldwide, all across the world, in all sorts of time zones. And they stored everything in Eastern Standard Time. And they just accepted the fact that, okay, well, when daylight savings time rolls around, we'll stay up, and if a call stretches across this period, then we will manually correct it in the database. And I just kind of hung my head in sadness, and I was like, why are we doing this? We need to convert stuff to use UTC. Like, this is a solved problem. We don't need to be staying up and manually editing records for stuff like this. Like, there's enough other stuff as software developers that we have to handle that, like, we want to make our lives easier. Like, there's more fun problems to solve than this. So yes, use UTC. So the same example going the other way, if the call starts at 1:45 a.m. before springing forward, call lasts 30 minutes. 30 minutes later, the clock on the wall will read 3:15 a.m. Because you went forward an hour. How do you record how long the call lasted? Again, this is a solved problem. Use UTC for stuff like this. Like, you're recording timestamps or stuff like pretty much right now, maybe very briefly into the future, and in the past, like, UTC is safe for this. It makes it easy. Time zone rules don't change for stuff in the past. Like, rules change for stuff in the future. Sometimes in the near future, like, it's not always very far in advance, but like, they never say, like, we're going to change how Eastern Standard Time works for 2015. Like, that doesn't happen. Like, rules change in the future. So by storing UTC for stuff right now into the past, then you can reason about it. It's a solved problem. It's this accurately portrays what time this event happened. So kind of back to our point, our tip, use UTC. But there are cases where UTC is not safe. So for future dates, it may not be very safe to use UTC. It might be better instead to store the time in the local time zone and store the time zone itself, not the offset, not -0400 or something like that. Like store the time zone, like America/New York or U.S. Eastern Standard Time. Store the time zone. If you need a value in UTC, then again, like use a computed column in your database for that. Like databases can help you with this kind of stuff. The idea that is sometimes spread around of just always using UTC and that being a silver bullet that solving all of our problems is just plain wrong. Let's consider this. In Knoxville, Tennessee, daylight savings time started March 8th, 2020, moving from -5 hours behind UTC to -4 hours behind UTC. Knoxville ended daylight savings time November 1st, 2020, moving back to -5 hours from -4 hours. In 2019, Tennessee passed a bill that would put Tennessee permanently on daylight savings time, if the federal government ever allows it. And guess what? 18 other states have already passed similar legislation. We have 19 states that if the federal government ever says, you know what, you can go ahead and do that, they are going to be changing all of their time zones. This isn't a hypothetical situation. This legislation's already been passed for this stuff. They're just not allowed to do it yet. So, with that in mind, take the example that you're planning a New Year's Eve party. It's going to be December 31st at 7 p.m. We'll use the Eastern Standard Time, Knoxville, as our example location here. And let's say you're planning this in August. And you've been told, well, you know what, UTC, I should always store stuff in UTC because that solves all my problems. So you convert that time to UTC, which would be January 1st at midnight, 2021. Because your computer knows that, okay, in August right now, it's -4 hours, but December is -5 hours. So we are going to adjust this time by 5 hours. Then in November, Tennessee's allowed to stay permanently on daylight savings time. They're going to stay on -4 hours instead of switching to -5 hours. Ruh-roh. Now, when you pull that date time out of the database and you convert it back, it's going to say, well, this is December 31st at 8 p.m. because the new rule for December is -4 hours, not -5 hours. So you're now going to have the wrong date time in your database. Even worse is maybe you just wrote an API that says, I'm just going to spit back whatever is in the database. If some computers have received the update to the time zone and some haven't, some will see 7 p.m. and some will see 8 p.m. That's a problem. I mean, maybe you want to be fashionably late to the party and, that's all right. But, this is a very real scenario. You could have, important events that, if you converted them to UTC because you followed the mantra that sometimes, put out there of just always use UTC, you're going to have a problem. So how do you solve this? Well, kind of going back to what I said, store the date time in the local time zone that event is happening in. Store the time zone information, not the offset. Like, I don't care about the offset. Store, America/New York, or, Europe/London, or, whatever the time zone is. But follow a specific database. There's different ones out there. So you might also need to store the version of that time zone. There were 6 different time zone databases for 2020 last year. Think about that. That's how many times that there were enough time zone changes that the overseeing entity said, you know what, we need to actually put out a new database for people to follow. If you need UTC, again, computed columns are your friend. So that kind of brings me to a couple side points. If you're creating consumer-facing applications, you may need to ask your users for their time zone. You can try to detect this in JavaScript. Most modern browsers will return the time zone with the international.datetime format .resolved options .timezone. Like, you can try to resolve that, but ask your customers. Don't assume that their browser is correct. If they're on a mobile device and they're traveling around, their browser might not be correct. So prompt them for it. You can auto fill in that prompt what their browser says they have, but double check with them. Prompt your users for that. If you need the calendar information, you can also get the calendar off of international datetime format .resolved options. So that is also available. So I mentioned that there's multiple ways to specify a time zone. Use a known time zone database. There's one included in Windows, which is updated every 6 months with Windows updates, which kind of goes back to the point of some customers of your application could have a time zone update and some could not have a time zone update. So, there's not everyone installs updates, at the same time. The other option is to use the Ionic time zone database. This is a much more thorough database. They had 6 versions of it for 2020. They update it pretty much as needed. Maybe not every little thing in the world that happens while they update it, but they update it pretty regularly. It's also better for cross-platform development. So if you have a mixture of Mac and Linux on your dev team, that's a good option there. Why use a time zone database? Because this stuff is hard and this stuff changes regularly. And you don't always get much notice before these changes. You can subscribe by email to the Ionic time zone database and they will email you updates, like when stuff happens. But think about this. Argentina gave 11 days notice for their decision to cancel daylight savings time for 2009. They just canceled it for 1 year, and they only gave 11 days notice. In 2011, Turkey gave just over 2 weeks notice. It was delaying daylight savings time by a single day. Like, what's even the point? In 2013, both Morocco and Libya gave less than a single day's notice before changing their time zone rules. We would love to think that, as difficult as this problem is, that there are a lot of smart people helping governments make these decisions and plan things out well in advance, but quite honestly, it really looks like people are flying by the seat of their pants on this stuff. This is a complex topic, and people just make decisions, it seems, quickly. I don't know, it blows my mind. So when you're storing date times like this, store the local time for future dates, store the time zone, America/New York, and store the time zone version, such as up until like a week or two ago, 2020F was the latest Ionic time zone database. So This is one you probably hear a little bit more often, and that is always use a library, never write your own datetime library. Like, this stuff is hard. Use things like Moment.js or Notatime for C# or Jotatime for Java. There's probably many, many others. These are just 3 that I've had some experience with. But use something that has been tested and people have confidence in. Like, because there's just so many things that you might not know about a particular region or a particular case. Like, this stuff's hard. So lastly, I want to touch on POSIX or Unix time. This is often another one that I hear as, well, just use POSIX or Unix time and you don't have to worry about anything. And I want to say, really? Let's think this through. First of all, POSIX time or Unix time is time represented by numbers. For example, this long string of numbers, 157788836 and a bunch of zeros, is Wednesday, January 1st, 2020, 8 a.m. Eastern Standard Time. I think the first thing you can see is this is not human readable. You're not going to be looking in your database and be like, you know what? Yeah, I know at that time. That was last Friday. Like, no, POSIX is not human readable. But some people really like POSIX, and POSIX has benefits. The Elm language, it's kind of a niche functional language, but the Elm language changed their default implementation for datetime in version 19 to POSIX from the Olson datetime format. What you're familiar with, year/month/date. And they put forth their arguments of why they thought it was better. And it does have some benefits, right? You can override time zone and daylight savings time information manually. So it gives you a little bit more granular control. Also, if you're running your applications on Linux, then you don't have to load a file for every time zone like you would if you were using Olson time zones on Linux. So there's a performance overhead that you don't have to worry about by using POSIX. But that doesn't mean it's all roses. Let's consider this. There is actually a thing called the year 2038 problem. And it's when systems are using signed 32-bit integers for POSIX. Things like MySQL's function Unix timestamp does this. It will return 0 after 3:14 a.m. UTC on January 19th, 2038. I am currently updating a point-of-sale system. We are rewriting a point-of-sale system that falls into some of this stuff. Like, there's a lot of legacy systems that do this. And that's kind of a problem. Like, we all love to talk about, we want to work on greenfield projects. We don't want to work on legacy code. But there's a lot of legacy code out there that has, problems like this that, we got to stop and think about. Like, this stuff's got to be fixed. You don't want your point-of-sale system rolling back to 0 on date times in 2038. Software lasts a long time. Look at the healthcare websites, for vaccines and for healthcare sign up. There's been issues of, hey, we need people who program in old languages because we need this stuff updated. Like, and if there's healthcare systems that are still running on really old stuff, and there's point of sales running on really old stuff, like, okay, this is something we need to think about. We're still in some ways waiting for Y2K. We just don't want to talk about it. Now, that being said, like, okay, there's a lot of modern systems that obviously don't fall to this problem. So, It's not all doom and gloom, but there are still systems out there that do this, and we need to be aware of that. A fun fact is NTP, the Network Time Protocol, that behind the scenes, like lots of the internet runs on, routers and switches and your laptops and stuff run on. Will roll over in 2036 back to January 1st, 1900 because of, again, a similar issue. So we need to think about some of these things. However, what I think is probably the most detrimental thing for POSIX, or up there anyway, is if you do a lot of data warehousing. If you have, you want to write applications that have tons and tons and tons of users. Like, you want to be popular, right? You want to be the next Facebook. You want to be the next, Twitter or whatever. Like, think about this. If you're gathering data and you need to be able to search that data, and you tell your database, hey, index on this column. If we look at the values of POSIX here, I have two dates on the screen. One is January 1st, 8 a.m. Eastern Standard Time, 2020, and one is January 1st, 5 p.m. Eastern Standard Time, 2020. There's only a 9-hour difference, but those values have a difference of 32,400,000. If you are having to deal with a lot of data, you want to be very, very careful about this. It is going to be really hard on your database server if it has to reorder data on an index on POSIX. That's not something you want to deal with. In fact, if you're doing data warehousing, you're dealing with large amounts of data. It can actually be better to split your date times and have dates in one column and times in another. And if you have enough data, it could be beneficial to break out those times into hours, minutes, seconds. It kind of all depends upon your use case, but your database is going to have a much easier time indexing on just a date column and then on just a time column than it is on those combined, or on POSIX, where you can have 32 million differences between 9 hours. Like, that's a problem. Like, you're not going to achieve massive scale if you're doing that. Now, maybe your application is doing POSIX timestamps and everything's going into the database in the exact order it needs to be in. And okay, then like your database doesn't have to do anything to index that. Like, it just is in order, right? Like, it doesn't have to reorder anything. So an index there is not going to hurt you. But you got to think about what you're doing. Now, say you have multiple systems like that, and you need to pull data from multiple systems into a single data warehouse. Your data is not going to be in order anymore, and it's going to have to index that. So again, I'm saying all of this to provoke you to think about your data. Think about what you're doing. Think about what goals do you have? Like, what's the goal of your system, and what data do you have to support it? And how do you need to use that data? These are all questions to ask. I'm not saying don't ever use POSIX. I'm not saying don't ever use UTC or anything like that. Like, there is appropriate solutions for appropriate scenarios. One last thing on POSIX is that this has the exact same problem as our future date example, because POSIX, as we mentioned in the trivia, is January 1st, midnight, 1970 UTC. Like, this is essentially a UTC date time. It's just in non-human readable format. So if you throw a future date in your database, because say you're using Elm and it's pushing you to use POSIX, I think they've kind of moderated that some now, but for a while they were pushing you to use POSIX, and so you are storing date times in POSIX in your database, and you're storing future dates in your database, and those time zone rules change. Like now you can't even just like look in your database and see what the values are because they're not human readable. Just think about, when you're writing your applications, what are you working with? What are you dealing with? How does your data need to be used? There's everything we've talked about tonight is appropriate at different times. And, you just need to evaluate, what that is and what's the appropriate solution for you. I've got some links here. The first link is the Ionic time zone database. Latest is actually not 2020F anymore. It's 2021A. That updated a week or two ago. I got the trivia from this from Notatime. They have a page with some pretty interesting trivia there. The third link is from John Skeet, who I have to say, like, I've learned the majority of what I know from him. Like, I'm not going to, stand here and claim like, yeah, I came up with all this myself. No, I studied and listened to people who are much, much, much smarter than I. John Skeet has several presentations on this kind of stuff. He's written some articles, like the one listed on why UTC is not a silver bullet. I highly recommend going and reading his stuff, listening to some of his presentations. He's just a really smart man. The fourth link there is a link from IBM, Red Hat on POSIX. The next link is a Wikipedia page on POSIX. It's got some interesting stuff. And then the year 2038 problem. And then the libraries, Notatime, Jotatime, and Moment.js. I really recommend, looking into libraries like those. I'm sure there's many others. I'd love to hear about some others in other languages. If anybody's got any, we can chat in the Zoom after this. But yeah, check those out. Also, if you have any questions, feel free to reach out to me. My email's there, tylerj@resultstack.com. You can also find me on LinkedIn. I'm actually no longer on Twitter, but reach out to me. I'll be glad to answer questions or bounce ideas off of. You can get the slides there at the bit.ly link. And also, if you're looking to change jobs or if your team needs help, hit me up. Love to talk to you. And terrifying but fun. Yes, that's
awesome.
The goal I was shooting for was terrifying. That's
yes. This is more of a horror style Cincinnati software craftsmanship. That's the way we roll here. So.
I'm not near as passionate about this as Neil deGrasse Tyson. That's I love this topic, but yeah, it's
cool. Well, I do want to say thank you so much, Tyler. You've done a fantastic job, and I really enjoyed your talk. Can we get a little applause in the chat here for Tyler?
Davey is right. I am available to do your time-based coding for $1,000 an hour. That's I'll go for it.
I think that was $1 million an hour.
Oh, $1 million an hour.
Yeah, I mean, how could you turn that down? So, excellent. Cool. Thank you so much, Tyler. We'll catch more good time date stuff in the Zoom afterwards. Definitely stick around for that. So also, is there anything that we want to call out? Is there social media where people should follow you? Anything like that? Or pretty much covered in the talk?
I'm not that exciting. I'm on LinkedIn. I don't really have anything else anymore.
Fair enough. That sounds good. Cool. All right. Catch you in a few, Tyler.
Thanks.
So, as promised, we are going to give you a free JetBrains license. So, I think that Kat is going to go ahead and announce that in the chat. Oh, she did. Well done, Kat. So, like the announcement says, to enter, you just type in hashtag CSC. Integer Man is opting out. I can understand that. Appreciate it. While everyone is doing that, I also want to re-mention that our next meetup is on March 3rd. You should definitely RSVP for that now while you are waiting. Give it another minute here for people to kind of do their thing. Go ahead and register. I'm going to drop that link to the, oh, awesome. So we drop the link to the RSVP. If everybody is in, I'll give you like, looks like everybody's done. All right. Kat, go ahead and draw for that license. 513 Colonel has won the JetBrains license this month. So, woohoo! Yes, that's right. So we'll get in touch with you and get your info so we can send that over. I want to say a big thank you to all of our attendees. We love you. You are our, you make Cincinnati Software Craftsmanship great. We would love to hear any feedback that you have for us. If you can think of any way for us to make Cincinnati Software Craftsmanship better, please reach out to us and let us know. And of course, you can message us on Meetup or find me on most platforms, of course. Also, do please join us on Zoom. I'm going to drop that link in the chat right now. And there we are. So I'll open that up here in just a second. Thank you so much for watching today, and we will catch you in the chat and next month. Take care.